All right. Hello, everyone. Good morning. So my second talk today will cover Winbind improvements. Serve yourself might indicate a little bit about what this is all about. There is a very important Kerberos extension called S4U2SELF. I really forgot to kind of send in some good description for the talk, so that was not really mentioned on the conference track list. But so glad you are here, and I'm happy to share some of my recent work, or well, actually not so recent work, but at least some work I did in the past months. So just very quickly, myself, my name is Günther. I work as a software engineering manager at IBM, at the Samba team since 2004, and at IBM I manage a team of engineers working on the Ceph SMB product, so to say. So one of the main problems that really we see in many scenarios, in many setups, in many customer calls, yeah, so it's a long discussion. What is a core problem that we need to address? And that is to really represent Active Directory user account data on Unix systems in a very generic fashion. So there's a big expectation that you have a full sync with group information, with user information, in particular with regard to group membership. And if you to speak to one of the vendors at SUSE, at Red Hat, and any other places, a majority of customer complaints is really, I typed the ID command with my username derived from Active Directory. Why isn't it showing my full group list? Why isn't this list really covering all the group membership that I have set up in Active Directory? Why are there missing pieces? Why it's sometimes empty? Why is it behaving in a kind of unpredictable way and not always kind of really complying with the consistency requirements that you have in your corporation and in your setup? To dive a little bit deeper how this is actually derived. So obviously the concepts of representing user account and group account data in both worlds is very different. You know about the SIDs that actually really define a entity in Active Directory, being a user or being a group, while in the Unix world you have IDs and then you have names kind of representing the ideas in a more comprehensible way. So there's always the core problem of really finding a mapping between the SIDs and the Unix IDs. We have this whole complexity of ID mapping, something I won't dive into in this presentation at all. So it all really boils down to have a proper understanding and a good notion of how do we get the SID of the user and how do we get the SIDs of all the group memberships that are really relevant to develop the Unix token information. And all this information typically gets acquired when a user authenticates to a domain controller. So regardless of the protocol, if it is NTLM-SSP or these days much more Kerberos, you will receive back an amount of information, authorization data you can call it, or in the NTLM-SSP case it's called, the structure is called the netar validation info. There are multiple calls that actually allow you to call. The most prominent one, this samlogon call, the first one in that list. In the Kerberos world, you receive the Kerberos pack, and in there you have a whole list of buffers, and one is the pack logon info, which carries basically effectively the same amount of data, the same amount of information, which is called in the Samba world this netar sum info 3 structure. And I copied really one example of my own account of this whole structure. It really covers multiple pages, and it consists of all the account-specific data, starting with timestamps, when I last logged on, when I logged off, when I last changed my password, my user account name, GD in this case, my full name, a whole bunch of other strings that might be defined. In my case, they aren't. The logon count, the bad password count, then the first ID information, which is the RID, which is then used to compose my main user SID, the primary group ID, which is 513, which translates to the domain users. And then you have multiple arrays in that structure that cover group information. The groups one is the first. So this printout really covers all the bitmap flags as well. So it's really a lot of information. But it basically effectively see that I have 1, 2, 3 entries in this group list, always only carrying the RID, which then needs to be added to the SID of the domain so that you have the full SID of the group. All that information is present in that structure. More bits defining user flags, the logon server I use, the logon domain, the domain SID itself, which is a very important piece of information, account flags defining what kind of account I have, what specific settings I have. In my case, for example, I have this flag set so that my password doesn't expire, and on and on. And then at the end, there is an additional structure carrying the extra SID group information, I believe, which is also carrying 2 entries. This last one here is a resource group. So we will see later that domain local groups are represented as resource groups in that token. So if you look back, it's really a tremendous amount of data. And this info tree structure is really very essential to many operations in Winbind, so to say. And because it is really so valuable and so important, it's of course a very sane thing to start caching this data. And since a long time in Samba, we have a distinct netSumLogon cache TDB that basically when a user successfully authenticates, we get this info3 structure in our hand. We take this structure and store it in the samlogon cache so that Winbind can pick it up later for all kind of other lookups if we need to have specific information about the user account, be it something for account flags, for names, for SIDs, and then of course also for group membership. So samlogon cache is really used everywhere in Winbind, and it's really very essential to have this information around. We also have a CLI frontend that allows you to interact with that cache. You can list the contents, you can show entries, you can even display this info3 view, which I had in my previous slides, this long list using the ndr dump command. You can delete entries and so forth. So it's quite convenient. But there are really also problems with the netSumLogon cache. And that is, first of all, these entries in this cache, they never expire. They're basically there forever. So someone comes along, authenticates, we get the structure, we save it, and it's then really never expiring. When they authenticate again, maybe then having a different group membership list because maybe an AD admin has changed something in the AD. Of course, the entry will be overwritten, so the most recent data is back in the cache. The other problem that also the cache has is consistency. If you think about a clustered setup with Winbind and CTDB, replicating information among all the cluster nodes, the samlogon cache is really only kept per node. So eventually you might end up having different caching information on different nodes. If you are in a scenario that you constantly log on, authenticate, get this fresh information stored in the cache, that's maybe not so much of a big issue because then the information in the cache will effectively be the same. But you also have to take into account applications that do not authenticate or a user just typing the ID command. Then it's not kind of part of the same workflow where authenticate and then cache store really makes sure that you have the most consistent data. So then you're really running into some inconsistencies. So I created a very small merge request recently to just allow you to basically expire these entries, which is really important for some scenarios that we'll cover later. In case there is no entry in the cache present because user never really authenticated, then Winbind is trying to at least compose the appropriate group membership using direct communication with the AD LDAP server. And the implementation has 3 different mechanisms that kind of also gives you an indication these lookups really are not the same thing, like really getting the information back from the DC, but it's more kind of an attempt to derive the same amount of information out of the LDAP server. And because all these methods, which I explain on the next slides, have their issues and have their specific behavior, we really have a code that really falls through all these three mechanisms, so trying really hard to get you the right list of group membership, but it's never really the same amount of quality or consistency that you would reach with authenticating and then getting the info3 structure. So the first one is the token groups LDAP operation. That's basically a base level LDAP search on the user DN, asking only specifically for the token groups attribute. I gave an example how you can basically repeat the same query with standard Samba utilities. So you can run this query. You will then typically receive a list of SIDs that the DC has qualified as being the right ones for you. That is, if it is working, if it's most of the time a good reflection of your correct group membership token, but there might be groups missing, there might be sometimes issues with doing the request per se, because the machine account, which is used for communicating with the LDAP server, might not have the right permissions or might be constrained in some other ways. So if it succeeds, the returned list of groups is very accurate, I'd say, but you cannot always rely on this query being successful. So if this query fails, Winbind does another attempt to do a base level LDAP search again on the user DN, querying the member of attribute using some LDAP ranged searching, because in particular if you have really a large user token with many group memberships, you might easily end up having thousands of entries returned, and then there are a way to do ranged attributes searches so that you can just basically iterate through pages of the returned result from the LDAP server. And again, I gave a Samba CLI utility example, how you can basically repeat the same query, again, using the machine account, of course. So there's code there that allows you to do and to repeat the same query. And if that also does not yield the results that you're expecting, Winbind even further falls through to a base level, a subtree LDAP search, basically on the entire user database, trying to find reverse memberships by looking for your membership DN in all the LDAP objects that are of the object category group, and then also gives a specific extended LDAP DN control to have SIDs directly returned as part of the LDAP result. So it looks a bit complex, but it's basically a way to try to be very effective in deriving a full group membership list token. But even that might fail or might not get the results that you are expecting. So as I mentioned, there could be permissions issues, there could be some groups not showing up in these queries at all. So it's really a painful thing, and really something that we would love to improve and to make something better. And luckily there is a nice extension in a completely different protocol, namely in Kerberos itself, that really allows you to basically mimic parts of the authentication and then the authorization token retrieval in a way that you do not require the user to authenticate, but to implement a concept of impersonation. So this impersonation mechanism is called S4U2SELF, a very technical term. If you look the great Microsoft specifications MS-SFU, which is the document covering this extension and how it's implemented and used in Windows, the definition of the S4U2SELF extension is the following. The S4U2SELF extension allows a service to obtain a service ticket to itself on behalf of a user. So what is a service and what is itself? In this example, or in our scenario, it will be Winbind. So Winbind authenticating with a machine account, obviously, that you have joined previously to Active Directory. And it will request a service ticket for itself, namely for its own service, for basically the same name, like also the name that was used in the initial authentication. And it will pass in the aspect of a user, which is then kind of the user that you are trying to retrieve the authorization information for. So along with the TGS request, so the request to receive the service ticket, there is an additional structure, send PA for user in our example. So there's also a way to do impersonation using certificates, which I'm not covering and haven't looked at. So we are only really specifically asking for information for a user. And then in the reply from the service ticket, you get this pack information for that user containing this pack logon info buffer, which is then containing this important info3 structure carrying all these necessary bits and pieces that we need to have to properly represent the group membership. So this mechanism is well implemented in all the Kerberos APIs. So there are two flavors. First of all, you can really use the raw Kerberos 5C API, or you can use GS's API mechanisms as well. I listed the functions. They have, of course, as always, different names in Heimdall and the MIT Kerberos library. But Samba really has code in place to detect what kind of mechanisms are available, what their names are, and then have abstraction code internally to hide these differences in the APIs behind the scenes, as we have it in so many places. And just really recently, I found out, or Alexander Bokovoy and Andreas Schneider from Red Hat informed me that they have created, or Alexander has created, a new API to provide an asynchronous stepping function set for the MIT project. Just because I got to know this so recently, I didn't really have a chance to took a deeper look, but I'm definitely very interested because that, of course, is definitely something that we would like to integrate as well. So we have the Kerberos API, and we even have in Samba a front end that allows you to call this S4U2SELF API using the net command that's present since many years. You can basically call netads Kerberos pack dump, which will then retrieve a pack for you and dump it out on the screen containing this famous info3 structure. And you can also give the additional argument of impersonate and then give it a user principal name. And then you will basically do the whole set of the impersonation control flow and print out the info3 structure out on the screen. So it's very useful to just quickly check, okay, if a user token is kind of matching my expectations, but it's not really a useful tool to kind of fill up the samlogon cache, for example. So it does really only print it out on the screen. It doesn't do anything else other than that. So the other important piece is that to use this S4U2SELF, we obviously need to know the user principal name. Because if you look at the APIs, I haven't really printed out the arguments in here, but the account that you want to impersonate for, that always has to be defined as a principal name and not as a SID or something like that. So we always need to get the user principal name, and we need to find it out on our own if we want to use this API. So what is the user principal name actually? If you don't have a user principal name set when you create an account in Active Directory, there is a common algorithm that basically consists of taking your SAM account name, which is your logon name or your UID or whatever you would like to call it, and add the @ sign and then the fully qualified DNS domain name. So in my example, it would be GD and then w2k25dom.ber.redhat.com. A domain name that I really use for a long time. that is kind of if you haven't defined any specific user principal name. But you could, of course, populate this LDAP attribute in Active Directory and give it a completely different name. I could choose not GD, but I don't know, AB or VL or ASN or whatever. And I can even make very deliberate choices on the second part, which is the domain name. So in Active Directory, you can define UPN suffixes, and you're completely free to choose whatever you really like. That's typically used to facilitate merges in AD if whatever one company acquired a different one and they want to kind of still reuse their old domain names from their older company. So they can just kind of map all these suffixes, they can all define them, and then really use them for their user principal names. So it's not really a one-to-one close relationship to the other account data, but it's kind of you have a lot of free choices and a lot of options for the user principal name. And for that reason, it's really important to, if we want to use this information, and if we want to use S4U2SELF, we need to have this information to have a sane approach. How do we find out a user's user principal name? And we could just use this another DCE interface from the DRSUAPI interface, which is an interface used for Active Directory replication, but also has a whole bunch of very important and interesting calls that basically serve as a front end to important information in the LDAP server of Active Directory. And one of the calls on that interface is called CrackNames, which is really a very generic way of doing all sorts of lookups. So if you're familiar with the internals of the RPC protocols and the LSA interface, you have LSA lookup SID and lookup names, which always do these typical name to SID and SID to name translations. But this CrackName interface really allows you to do much more. You can basically always define what the input, what the output is. You can ask for as the input parameter, for example, is SID, and the output you would like to have the user DN, for example, for the LDAP tree, or the name, or this, or any kind of other information that would kind of reflect to the user object. And there also are ways to specifically ask for a user principal name. So you can feed this DS CrackNames API with the SID and ask it to give you back the user principal name, so that you don't have to do all these lookups in the LDAP tree manually and take into consideration the UPN suffixes and all these things. So I was just trying out if we couldn't just use this interface directly from Winbind itself, and that's a very easy and straightforward thing to do. So I will demo this in one of the next slides. So that's probably the most programmatic and safe way to do this user principal name lookup, which we need to have in order to feed the S4U2SELF engine. Then I also learned, and I also experienced this in actually some of my tests, that these Kerberos functions in general really could block for some reason. It could be related to networking issues, it could be related to the sometimes insane and somehow uncontrollable way of DNS lookups that the Kerberos libraries tend to do. So if we put an S4U2SELF client into Winbind, then we really need to take into account that we would really put a very risky communication, very critical code in central pieces of Winbind, with the potential of really blocking the entire operations, which of course is totally unacceptable, because all the requests in Winbind, they need to be asynchronously processed, so that Winbind is always able to receive new queries and can operate in a very responsive, highly responsive way. For that reason, I just moved all these impersonation business into a separate Winbind process, which is forked off the main Winbind process, so it's also having its own log file. And then in this call, in the separate Winbind, in the separate Kerberos child, I only have an implementation for one call, which is this Kerberos impersonate token function that takes the impersonate principal or user principal name or wherever you would like to call it, and then just returns out of the derived authorization data the list of group memberships, or if you ask it for, then you even can return the entire info3 token. You had a question, Volker?
I mean, isn't that exactly why Metze was working on this being completely asynchronous and all the DNS and name lookup being done in Winbind? So the idea was to just have the Kerberos libraries prepare a packet to be sent to a realm, get the answer from Kerberos libraries, please send this packet to that realm and feed me the answer. So that Winbind is in complete control of the domain controller lookups. For example, the way I've seen it is that the Kerberos libraries are not site aware, for example.
Yep.
And so this is why we need to completely liberate ourselves from libkerb5 in whatever flavor to do the DNS lookups themselves. We need to control this in a completely asynchronous fashion.
Yeah, exactly.
And so I don't know if a new child is actually the right approach here. For a prototype, okay, but not for the final implementation.
Yep. Yep. To maybe quickly repeat the question, Volker was pointing out that Metze and others maybe also have thought about, couldn't we just have an API that basically allow us to do all these potentially blocking and potentially uncontrollable lookups, in particular for DNS and for finding the right network path to the KDC in Winbind, because Winbind has the knowledge about site awareness, so concepts that don't really are properly implemented in the DNS lookups that the Kerberos library do, and then be in charge of basically just using the find the right routing, find the right domain controller to send this packet to, and only instrumenting the Kerberos library for the cryptographic pieces, and let us, Winbind, be in charge of all these all the communication flow. Yes.
One sentence. libkerb5 should not talk to the network at all.
Yeah.
So the problem is much deeper.
Oh, thank you.
Yep.
I love deep problems.
Yeah. So and exactly because, as Alexander pointed out, there's so much more complexity. I was just trying to see, okay, what can we do right now? Okay. How can we maybe solve 80% of the use cases, or maybe even less?
We shouldn't start the discussion now.
Yeah.
Just finish it.
Right. Okay. Yeah.
I want to point out that we have two ways of using Kerberos mechanism. One is the raw Kerberos using the libkerb5 library. Another one is through GSS API.
Yeah.
And certain things only accessible over GSS API. For example, IAKerb is GSS API extension. The use of tools like GSS proxy is only available over GSS API. So you cannot use Kerb5 directly because with GSS proxy, for example, because it's not triggered there, and you don't see credentials stored in the cache because they stored in encrypted form, only visible to the GSS proxy process, which is running somewhere else. So this is the part that.
One remark regarding GSS API. My understanding of GSS API is that I call a library, I get blobs that I ship to the server, and
Yeah.
GSS API tells me. So,
Yeah. So GSS API.
Is that the libraries don't talk to the network. It's
Yeah.
me who talks to them.
GSS API has support for asynchronous.
No, I'm not talking about asynchronous.
No.
I'm talking about the GSS API prepares blobs that I
Yes.
ship to the network.
This is exactly how GSS API init secure context, accept secure context is built. That's effectively asynchronous way of handling blobs. And with the one exception, S4U extensions are not using that. They are done in a different place in GSS API. Well, well before we get there. This happens when we acquire credential, not when we are building the exchange things. And this is exactly what my pull request implements. It differs to the later stage so that we can get these tokens generated. Answering your question about the DNS communication, that solved problem already.
Okay.
That is already handled by both Winbind and SSSD. They provide Kerberos snippets that stick you to the specific site servers, and on the libkerb side, they read these snippets already. It's transparent. It's not as elegant as you would have from the application side, but it's basically overriding configuration for all system applications at the same time.
Mm-hmm.
Yeah.
Yeah, thanks for having that discussion. So actually, let's try to demo that. I wanted to record the demo, but I couldn't really figure out the right sequence, so let's have a live demo. Can you see my screen? Yes, you can. Okay, so what do I have? I have an Active Directory domain controller, obviously, idling around here, hopefully still running. Yeah, so it's there. 10 o'clock. Hopefully the time matches also the time on my computer. It does. Okay. So let's just basically clean up my system so that you can trust that I'm not kind of having some weird stuff here. In particular, now there shouldn't be any entries in the netsumlog on cache, so nothing is there. And really the entire system got wiped out. Winbind is not even running. Let me actually prove that. Okay. Yeah, no Winbind. Okay, so let's do this again. Oh, now first let's basically quickly demonstrate this impersonation API. Maybe without the impersonation userPrincipalName. If I just call this function like that, it basically authenticates as the machine account itself, and for itself it receives a Kerberos pack carrying this information for the machine itself. So you see my machine is named MT Helena, and it will have a very limited group membership because it is a machine account, obviously. So nothing fancy to see here. And if I want to call the impersonation API, which we have in Samba right now, today, let's, for example, use my user account and impersonate as that, call it, then we see in the return content, again, this info3 structure that I've showed you earlier. So exactly really reflecting all these bits and pieces that have been talking, all the group memberships with resource groups, and everything is basically part and can be accessed using the S4U2SELF mechanism without really Winbind being even running or something like that. So this is just a query on my machine. Again, the samlog on cache is empty. So now let's just do the full thing. I kill Winbind again, I clean up my machine, I start Winbind, and then I run the ID command for a user that apparently never really has logged on and never really authenticated. So it returns my full token. And if things go correct, now we have also an entry in the samlog on cache, which means that we have received this really very important and really very consistent set of data using Winbind by just typing the ID command. And now ID command is really something that I type on the console, but if you think about other applications, for example, NFS Ganesha, which also has a way to communicate with Winbind for ID mapping information for token group membership lookups and stuff like that, it can really retrieve that way the exact same amount of information as if the user would have authenticated and the domain controller having attached all this authorization data in there. And you will also see that this Winbind child process has received this impersonation call. Kerberos doing its magic, being very verbose at level 10. It has received the Kerberos pack. We print it out again. We store it in the samlogon cache and of course print it out again one more time. And then in the end, this call returns with the list of group memberships, with all the SIDs. And because it was asked to do so, it even adds the entire info3 structure again. And of course, we print it again. So it's very verbose, but I mean, it's, I think you basically get the whole communication flow. Yeah, and now we have this information in the samlogon cache. Really nothing more to show. Yep. And let me come back to the remaining slides. Oops. So, what is next? So, first of all, I mentioned the limitations. In particular, I made some safeguards in there that we only support it really in a single realm scenario. So basically the account that is doing the impersonation, in my case the machine account, and also the user that I want to receive the information for need to be in the same domain. That is because if we would request information in a trusted domain, then there will be KDC referrals in place. There will be more ways that more obstacles probably in the way when these KDC referrals are chased, which could delay the whole set of operations. So I didn't really want to go that route, even if we have it now sorted out in a separate child and operating on this asynchronously. I just kind of want to limit the scope that this is something we do only for accounts in our own domain. And also,
this is not a problem for the protocol. It's the implementation choice.
Yeah, exactly. Yeah. We could also maybe make this configurable or find some other ways, or just really to do some more testing about this, which I didn't really have a chance to do so. And also the UPN suffixes should also be fully supported. Right now, I think most of the time they will be working correctly, but if you really want to have the full chain of functions that you basically can call the ID command with a UPN suffix, a user principal name, to really then get the same set of information using S4U2SELF and all these things in place, that's not fully operable right now, and I need to just find out where the remaining glitches are. At least all the infrastructure we have in place, we have the CrackNames call, we have support for the Kerb5 enterprise principles that we can feed these UPN suffix principles to the S4U2SELF API. So
if you do set
the canonicalization and enterprise principle flags in S4U2SELF request, it should be the KDC's headache, not yours, to resolve the UPN. So basically, whatever is put by the user can be treated as a UPN, and then KDC has to resolve it. That's what they do for any user principal. There are some catch-ups, as that in some cases maybe it's only done for ASREC, and this is TGSREC, but it should be workable. Yeah. There's a second form that you mentioned is by using X509 certificate, and with that one, KDC is supposed to use that certificate to figure out what is the username. Effectively, you are not even passing the name; you are passing the certificate, but you don't have that certificate on your side, so you cannot really use that. And yes, as long as you have bidirectional trust, you can travel to the other domains and pick up this information from the other domains. It would have been nice if we can, as a domain member, delegate this to the domain controller. Probably we already could and wire up the S4U2SELF on the domain controller instead, so that domain members always use the DCRPC calls within the domain, and then domain controller does the S4U2SELF and caches that, because that also gives you a chance to cache, be more cache effective for all domain members.
Yeah.
And they have direct access to the domain controllers from the trusted domains.
Right, yeah. Would that be then the S4U2 proxy?
No, it would be the same as for you to self. The domain controller would do S4U2SELF on behalf of the username that the domain member passed through the normal request. So effectively, you don't run this S4U2SELF on the client machine. Instead, you run it on the domain controller, populate Winbind cache there.
Okay. One word about caches still. If we would have all this infrastructure in place, and if I manage to convince Metze and others and you and test your patches to really get this into the tree, then we could finally start expiring the samlogon cache, right? Because we have really situations and we have customer scenarios for NFS Ganesha. Maybe they authenticate once against Active Directory. There is a samlogon cache entry generated with information about their group membership token. But then, for some reason, they never authenticate again. But we need to kind of look up this information. We need to use this group membership token, which might be completely different in the meantime, because the AD admins might have changed the landscape of their membership altogether. And then we would just use this stored and stale samlogon cache entry forever, because we have no way to basically refresh that amount of information. And if we have this infrastructure in place, then we can say, okay, every 30 minutes or so, we just throw away the samlogon cache entries, and we can always regenerate them using S4U2SELF API, right?
And
so this will be, I think, a dramatic consistency improvement, then, in particular for clustered setups.
You will never be able to get the true details, even through S4U2SELF, in the environments where dynamically populated groups exist. You will see this in my talk later today, that there is one particular setup that can be used with Active Directory where you get the group membership populated depending on which type of the smart card mapping was used for the smart card, but S4U doesn't deal with the actual login. It simulates the login. So you will never get these groups populated that you would otherwise populate with the real smart card login. And that's by design.
Interesting, okay. All right, so yeah, I have to clean up this merge request, and I'm really happy to discuss this further with you. I gave you also a full list of all the references. There's also a very good MIT Kerberos consortium page describing the implementation of S4U2SELF in the MIT Kerberos project. And then of course various protocol documents from Microsoft, which are really very helpful and explain the scenarios very well. And this is it. Okay.